Welcome back. Last time we worked with some equations involving compounding and exponentially increasing interest and accrued money. But unless you've won the lottery or you inherit a large sum of money from your great aunt, you likely will not be using these equations anytime soon. The fact is, most of us will be spending the majority of our lives in debt, paying mortgages on homes and cars, and using much more complicated equations, which we'll cover today. But I had to start with the explanation somewhere. Anyway, today's concepts will use those ideas as a base, but will likely hit a little closer to home. Let's talk about a more realistic way of paying off mortgages or saving money called annuities. Remember when we started talking about saving for some amount of money? We'll call it the future value. We did this problem. How much would an investor accrue putting a block of money, like $1,200, in the bank at an interest rate of 12% for 5 years? And we use the compounding interest formula. We put in for the principal $1,200. We put in for the interest rate, in this case, 0.12. We didn't even talk about compounding in this case, okay? And in this case, after 5 years, we used our calculator, and we got an answer of $2,114.81. Sounded very good, very mathematical, but there's no way, at least with me, that I'm going to have $1,200 to throw into the bank at one time. That's not the way you save money, is it? You don't take one giant large amount of money. You put a little bit in at a time, every month, or every paycheck, every other week, or something like that. So let's talk about what that really is an annuity. You hear this fancy word, annuity. An annuity is a regular payment, an agreed upon sequence of payments made at a regular time, like every month or something like that, either to pay off a loan, like your car payment that you make every month, or to save a certain amount, okay? Save for retirement. You're going to hear a retirement account. People put an annuity into their retirement account. That's a regular payment. Or to save for education. Or, of course, your mortgage is something you pay every month. Or your car loan is something you pay every month. It's a regular sequence of payments. It's not some one large block. And the math involved with that is a little bit more complicated, isn't it?
Yes, you're in deep dough now.
Let's get back to saving this thing, okay? What if we try, we have that $1,200, and we're going to put it in every year at the same interest rate, 12% for 5 years, but we're going to do a little bit every month. That's why I picked $1,200. After the first month of my $1,200, I'm going to only put in $100, okay? So I'll have my original $100, plus I'll have 100 times, not 12%, because you only get 1 month's worth, right? So 100 plus 100 times 1/12 of 12%. That's why I picked that nice sweet number. That's after 1 month. After a month, you'll have $101. Okay, that's not too bad. What happens after the second month? Well, after 2 months, of course, you have your $101 from the first month, plus a new 100 that you put in. Okay? Plus, of course, that makes $201. You get an additional 1/12 of 12% for the second month on that $201. So you get $2.01 added to your $201. So you get $203. That's after 2 months. You have $203.01. Okay, that's after 2 months. I got to work myself through 5 years here. After 3 months, holy mackerel, we're going to have our $203.01 plus another 100 that I put in. Remember, I'm putting in 100 every month. So let's see, that'll add up to $303.01 plus I get my third month's interest, which is 1/12 of the annual 12%. Well, let's see. That's going to equal... This is way too hard. It's a nightmare. I've got to come up with... I can't go on like this to figure out the right amount that I'll have at the end.
As always, should you be caught or killed, the secretary will disavow any knowledge.
We're going to come... This isn't going to be that bad. We're going to come up with a formula for this. We'll let T, as usual, be the number of years. M will be the periods per year. For instance, monthly, M would be 12. Okay, we worked with that before. P is going to be the payment I make per period. So in this case, we were paying $100 a month. That's a new one now. Okay, your payment per period, your regular payment, the little p. And R, we worked with before, that's our annual interest rate. That's the rate that you would get per year, not per period, not per month, for instance. Well, so we have a new letter here we're going to call I for interest. Now, R is the annual interest rate. I is that annual interest rate divided by the number of periods per year. So, I guess I, you could say, is the interest you get per period, right?
I know that, dude.
Okay. And N is going to be the total number of periods in the whole shmagunga, the whole life of the loan. Because if you go for T years, and for instance you pay 12 months a year, and the M was 12, N would be the number 12 times the number of years. Okay, N is the number of payments, the total number of payments in the full life of the sequence. Well, the formula that we're going to use, we're going to call it a future value, not an accrued. Remember, last one we called accrued. That was on a basic compounding formula. This is a future value, which is supposed to tell you that you're using an annuity, a sequence of payments. And your formula is going to be little p, the payment that you make every month, times what we have here. Okay? Note that we have R over M in there, so we could possibly simplify and replace every occurrence of the rate divided by periods per year, R over M. We could replace that with I.
I'm back, baby!
Okay? And some people do that. So let's think about this problem all over again, thinking of it as a future value
What am I gonna do?
in monthly payments of $100.
Oh, will you help me? Can you help?
This formula can definitely help us. It looks terrible, but it's not that bad. That's what we're going to... The payment per month is going to be $100 because I had $1,200 to put in every year. That's kind of my budget, if you would. Rate's going to be 12.12, 12%. M's going to be, since it's monthly in this case, and that's a common one, M is going to be 12. And T's going to be 5 because we already stated that it's going to go for 5 years. Look what it comes out to. Okay, and that's something you could put in a calculator.
What's all this jabber-wopping when there's work to be done?
So get busy. Okay, put that in, and remember, anything that's in a exponent has got to be in parentheses.
Whoa!
Or it's going to use the order of operations and give you, it's going to give you an answer, it'll just be wrong. The answer, after you put this in, now note, let's look at the parentheses we should put in. I always put at least 4 sets of parentheses. Note that I put the whole numerator in a set of parentheses. That's red. Okay. I put the whole denominator in a set of parentheses. That's green. Okay. Then I put the part of the formula 1 plus, R over M in parentheses. That's blue. And of course, and this is the most common mistake, I had to put any exponent in its parentheses. See the 12 times 5. If you don't have all 4 sets of those parentheses, you're going to have a wrong answer. The answer you should get, in this case, you should save $8,166.97. That's a future value of putting $100 in every month for 5 years. Okay, one interesting permutation of this formula that we've used is to solve for the present value, for the big P.
Now cut that
Yeah, well, this is probably the most useful of all if you solve for the big P. Remember, that's the amount that you borrow. Okay? Did you ever ask, how much can I borrow? How much can I afford? Well, I'll tell you how, you need to decide that. And you can't go by anything other than how much money do you have in your pocket every month. Don't go by, I want that house. Or the Joneses have that house, so I should be able to have that house. I'm as good as the Joneses. That's not the way to do it. You may be able to afford more, or you may not be able to afford that, and you get yourself into deep poop. Okay? So we're going to find out by putting in a little p, the amount we can afford every month, and answering how much we should borrow. What should we be shopping for? How much house can we afford? Okay? And it's not just with houses. You might say, for retirement, how much do I need to save to be able to, maybe you have your plans, I want to spend $1,000 monthly for 4 years in college. Okay? Depends on the percentage of the account, of course. So these are the kind of things that you might ask.
There's something I have to ask you.
So let's figure this one out. Right now, and this is a typical person's in this, some people are in this situation. If you're paying rent, that's no good. That's no good. You want to buy a house. Okay? You know you can afford $900 a month because you pay $900 a month rent. And most people pay more than that. Okay? So let's ask the question. If you know that you can afford $900 a month rent, and you can get a 30-year loan at 7%, which at least right now as I record this, I know you can do better than that. How large a house, what present value should I be shopping for, knowing that I can afford that? Well, let's put the numbers in. The $900 is your small payment. We put in our 7% and our time, 30 years typically for a home.
This is a job for you know who.
Put that in the calculator. Okay, and once again, to the point maybe where you're sick of it, make sure you put parentheses around the numerator, around anything in the formula, around the denominator, and around any exponent. That's 4 sets. You probably should have every time. And what does this come out to? We should be shopping with those variables for a house for $135,000. I bet you can find something, maybe a condo. Got to get started with something. Now, don't forget to consider tax and insurance. Okay, and that's typically about 11% or so, or 10%. So what I tell people to do is to take that number and divide by 1.1. That takes out the 10%. It gives you a realistic figure.
Now I appreciate that the mathematical formulas we just showed you are relatively complicated, and I want them to be useful to you and easy to use. So we're going to go back to our old buddy, the spreadsheet, and take a look at a way to have these things calculated for you much easier. What we're going to use is the function wizard. Let's review the function wizard in Microsoft Excel. All the spreadsheets work pretty much the same. Let's take a look, for instance, at, I don't know, doing the average of these numbers. Remember, the function wizard is going to be on the f of x button, and it'll automatically put in the equals for me, so this will be a value. So if I hit f of x, okay, it's going to give me what we call the function wizard, as you can see right in the middle here. And I can look for a function. I'm going to have to know that a function exists, but at this point I can search for it, but I'm going to leave that to you. We're going to use the average function, and I've already set it, and I'll say OK. Now, these little symbols are actually pretty cool. This is supposed to be a picture of you, that's a red pointer, even though our pointer isn't red, pointing to something in the spreadsheet. So I'm going to click on that, and it's going to get me to the spreadsheet and allow me to point to something. Before I do that, though, note that the button has changed to a picture of the function wizard. It's not a very good picture, but that's the idea. So if I click on that, it gets me back to the function wizard. So let's do it again. Click on the little button to go to the spreadsheet. And now I can point to what I want the average of. We'll call this a parameter of the function, what it references. And I'll select these cells. And now it's time to go back to the function wizard. So I'll click here, and I'm back in the function wizard. And nicely, it actually tells me what the result of the formula is going to be. Basically, I'm checking that to see if it's reasonable. Okay? And if I was wrong, I could go back and repoint, but I think I'm okay, so I'm going to click OK, and son of a gun, it gives me the average. Let's do that one more time and get the average weight of these guys. So I'll click here, go to the function wizard, which is right here, and I'll pick average. Of course, I could pick any of many functions from any of many categories, which we'll come back to. Okay, but I'm going to pick average and say OK, and I'm going to point, so I'm going to use this button to send me to the spreadsheet, point to what I want the average of, and then come back using this button, which is supposed to be a picture of the function wizard, and I think I'm okay, so I'll click OK, and I have it. So that's the idea of using the function wizard, and in this case, everything only had one parameter. The financial functions that we're about to use have generally 3 parameters every time. The possible parameters, let's look at the vocabulary for that. Now, I use the term vocabulary because the following words can be parameters that we're referencing in the spreadsheet of these financial functions, but they can also be results. For instance, we can actually be finding the rate, but whenever we reference a rate, you need to understand that we're talking about, usually you're talking about the annual interest rate, and you store it as 6% or whatever in the spreadsheet. Whenever we reference rate in a spreadsheet, we're talking about the interest rate that is paid per payment or per period. So very often, for instance, if it was a monthly payment, you would be putting in 0.06% divided by 12. If it was a weekly payment, you'd be 6% divided by 52. It's the interest rate per payment. Now, normally, we're going to store that in a cell, so we'll be referencing it, and your parameter will be that cell, which in this case, the example is B4. But again, you'll have to alter it to divide by 12 for monthly, or divide by 52 for weekly, or whatever. Okay? We don't use the word term in spreadsheet, which is the idea of how long the annuity goes. We use the NPER, which is supposed to represent the number of periods, the number of payments you make in your annuity. So, for example, if it was a 30-year term for a house, it wouldn't be 30 payments, there'd be 12 times 30. And of course, we'd probably reference a cell in that. So, and here's an example of a typical auto loan, a 5-year auto loan, which would be B5 times 5. Okay, kind of a deal. Now, we're going to be talking about your payments. In any spreadsheet, payment, or PMT, is going to be related to the amount of each individual payment. But any spreadsheet is going to, all payments, so that it's consistent with your accounting, are going to be negative numbers. Get used to that. Any payment is a negative number. If you don't put it in as negative, you're going to get, weird answers. Probably we're going to be referencing a cell on that as well. Okay? And then we have 2 more, because we're basically going from things saving to the future. So PV is going to represent the present value of something. If you want money, if you want to borrow, it'll be the amount of money that you're getting now. For instance, if you're buying a house, I need to borrow the money for that house, maybe a house that costs $209,000. That would be the present value, and that's probably stored in a cell somewhere. Doesn't have to be B5, but probably we would be referencing a cell, and I'll be giving you examples of that. And if you're saving for something rather than borrowing, we're going to use the FV, or future value, which is going to be the amount you hope to have at the end. For instance, perhaps you want $587,000 for your retirement. Okay, that would be the future value of a bunch of payments that you're making as you work through your 40 years of work or whatever. And again, most of these things you're going to store in a cell. Okay, let's start looking at some individual examples of using these financial functions and not having to do all this complicated math. For instance, the spreadsheet can relatively easily calculate the future value of a series of payments, an annuity, using the future value function. Let's try it. Suppose that you wanted to save for a down payment on a home, and you knew that you could afford every month a payment of $100 to save for that, okay, out of your paycheck or whatever. You knew that you could put it in a bank and get 4.5%. We can change that to whatever you thought, but that's the idea. And you were going to save for 3 years. I wonder what that series of payments would be worth in 3 years, paying $100 every month. As we saw before, that would be kind of a complicated calculation to do on paper. So we're going to use the future value function, and I'm going to reference these cells. So I'm going to go to the function wizard, and I'm going to look for FV. Search for the function future value, and son of a gun, it found it. Okay, and there it is, and I'll say OK. Now, it's trying to help me. There's a bunch of things that I need to know. I need to know the rate. So I'm going to point to the rate. I'm going to click on this little button here that tells me to go to the spreadsheet, as you remember, and I'll point to the rate, which is right here, and click. And then I'll come back to the wizard using this button, which is a picture of the wizard. Now recall that the rate is the rate, not the annual rate, but the rate per payment. We decided that this would be a monthly payment. So I'm going to adjust that and type in divided by 12. Almost every time you'll do that. Okay. Now the NPER, or number of periods, we know that this term that we're going to save for is 3 years. Now I could type 3, but I'm going to reference that. So I'm going to click on the button to go to the spreadsheet, and I'm going to point to that cell. That way I could change the cell and see how the calculation changes. Now I'll come back using the wizard. But remember, the number of periods is not the number of years. We have 12 months in each year. So as typical, I will have to adjust that and say times 12. Very often you'll be doing that. If it was weekly, you'd do times 52. And finally, I need to put in the payment. You don't have to put them all in. It suggests to you in bold which ones you must put in. Okay, and I'll point to that as well because I have it stored in the spreadsheet. Clicking here, I see the payment is right here, and it's negative. That's appropriate. And I'll come back, and pretty cool, it tells me, as you can see, what my formula result will be. Okay, so if that's a reasonable answer, I think I'm going to click OK. And son of a gun, that's how much money I would have putting $100 in every month at 4.5% monthly for 3 years. Now, I hope we appreciate that I have reference cells in that so that I could change those cells. For instance, change this to $200, minus $200, and as soon as I hit enter, hopefully you'll see that amount changes. That very powerful what if possibilities you see. Now let's, just for interest's sake, let's see what the future value saving for retirement would be of putting $300 in to a 6% account for 40 years of your long hard work. Okay, so I'll sit where I want that future value function, and I'll basically do the same thing many times so you get the idea. I'll click on the f of x, or function wizard, and this time, again, I want future value. Since it's the last one I used, it's already at the top. I'm going to go a little faster now and click on OK. Now, the interest rate I'm going to reference, so I'll click here, go out and reference it, store it in a cell, come back using this button, and of course I have to adjust it because that's the annual interest rate, so I'll have to divide by 12 and get the monthly interest rate. Now, the number of periods, I'm going to point to the term, which is 40 years, and come back, but the NPER is the number of periods, not the number of years. So I'll have to take the number of years and multiply it by 12. And then, finally, the payment that I've decided to, hopefully I can afford every month. I've referenced it in a cell. And notice that it's negative. And I'll come back. And nicely, I see that if I make that investment, I will have $597,000, hopefully, to retire on. And I'll click OK, and that seems appropriate. Wow, I wonder if that's not enough, what am I going to have to do? Well, maybe I'd have to put in more money, maybe $400. Maybe I can't afford $400, and I have to get a higher interest rate. Or maybe, oh my, I might have to not be able to retire for 50 years. As you can see, oh, this got to be too wide, so I'm going to come up and widen that. And I can see, well, 50 years, I'll slash my wrist by that time, so I don't want to have to do that. But anyway, that's the idea. Okay, let's go back to 40 years and see the what-if possibilities of the future value function. Now let's work backwards, because we already know the answers. We'll pretend we don't know the answers of the future value function using the NPER function. And the NPER function, or number of periods, answers the question, I wonder how long it would take me to save a certain amount of money using a series of payments. Now we knew from our future value function that going $100 at 4.5% for 3 years is going to be $3,846 and some cents. We know the answer, but let's do it anyway. I wonder how long it would take doing this series of payments to get this amount of money. So I'm going to use the NPER function. I'm going to go to the function key. I'm going to search for NPER. I know that it exists, and son of a gun, it jumps it right up to the top. And I'll click OK. And again, it asks me pretty much almost the same questions in the same way. I'm going to point to them because I have them stored in cells. I'll click on the pointer button, the interest rate, and then come back. And remember, the interest rate is per payment, so I have to adjust to divided by 12 because the 4.5 is per year. And the payment is stored in a cell. I'll click on the pointer button and click on that and come back. No adjustment needed here. Now, here's where it changes. Okay? We need to tell it the future value of what we want to save. So you have to know what you're looking for. I want to save that much, so we're not going to answer the present value. We're going to answer the future value. The present value would be if you already had some money. Okay? So I'm going to point to the future value, okay, which is a positive number, hopefully, okay, and I can see the result, which remember is the number of periods. Let's say OK. So I need 36 periods. Do you recall how could I adjust 36 monthly payments? How could I adjust that in here to be per year? Well, I think what I would do is say equals, reference this cell and divide it by 12, and I already knew the answer is 3 years to save that much money. Let's do it one more time and find out for our retirement the number of periods, or also the number of years it would take to save this amount of money. Now recall, from our future value function, we kind of knew that it was 40, but let's work backwards, just pretend we didn't know. Okay, so again, I'll sit in the cell that I want the result, go to the function wizard. Okay, I'll use my last NPER and say OK. The interest rate, I'll reference right here. I have it stored as 0.06. I could have formatted it to 6%, but I didn't. Okay, we'll click back. Remember, interest rate is per period, so I'll have to divide by 12. Now, sometimes you might divide by 24 because you might have a bi-weekly or a bi-monthly payment. That's why we do it this way, to give us the flexibility. But most of the time, it's going to be divided by 12. And I think in your homework, almost every time it'll be divided by 12. The payment, which is negative, will reference, which is right here. We said we could afford $300. And we'll come back. And again, we're going to use future value because I want to save to that. And I'll reference that. I want to save to this amount. This is what I think I need in retirement. Okay, that's a tough question there too. And I'll come back. And it tells me 480 periods. Does that make sense? I think it actually does. Because if I click OK, 480 months, if I adjust that to be how many years, I'll begin with equals and say I want this cell divided by 12. How many years? Do we remember what that was? 40 years. Okay? Son of a gun. So how many years would it take me to save this amount of money is answered here. And of course, I can adjust this. If I said, well, I can't last 40 years. Okay? What if I decided to pay more? What if I said I'll pay, I don't know, $500 somehow every month? Let's see, when I hit enter, oh, I just got retired 8 years earlier. So you see the power of referencing in your financial functions. Okay, just my opinion, but I think I've saved the most useful two functions till the end. Let's talk about the payment function, or PMT. Of course, in your financial world, you're going to be wondering, I wonder how much I would have to pay to take out a loan, or to pay for a house, or to pay for a car. I wonder how much I would have to pay every month, kind of a deal. Okay, again, that's kind of a complicated math calculation on paper, but the function wizard will do it for me, as long as I know what function to use. So that would be the payment function. I wonder how much I would have to pay for a $23,000 car that I've picked out. And of course, car loans are a little more, at 11%, if I do it at a 5-year term. I wonder. Let's do it in a referencing manner so that I can change things. Now, this is only going to be the principal and interest on that loan, okay? Not taxes and insurance, which we'll talk about later. Okay, I wonder what that payment would be. Well, let's go to the function wizard, and we want the PMT function, and I'll search for that. Go. And son of a gun, it found it. And it's going to help me. You're going to say, well, Witte, these are all the same. And they sure are. So let's reference rate. In this case, it's 11%. Now that's per year. So we'll come back and adjust it to monthly divided by 12. Now the number of periods, it's not the term, but I've stored the term. So I'm going to go out and get the term. Now that's 5 years, but that's not the number of periods. So I'll have to come back and adjust that, multiplying by 12 to say how many months or how many periods of payment are going to be. Okay, and finally, I want to know the principal that I want to borrow now. Now that's going to be, I'm going to borrow it right now, so it's going to be a present value. Okay, so I'm going to point to that. $23,000 I need for that car, and I'll come back, and as I can see, the payment is negative, and remember, payments are always negative. So let's click OK, and son of a gun, your monthly payment to buy that car in these situations would be $500. Okay, and if you say, oh, I don't know if I can afford that much, well, then you'll have to either do it on a longer term, which I don't think you're going to get longer than a 5-year term, or you're going to have to buy a cheaper car. Let's say we adjust it to a $15,000 car, and I hit enter. My payment went down significantly. Okay, let's talk about doing the same thing for a home. I wonder what my payment would be for a $190,000 home at 5.3%. over 30 years. Typically, we buy a home over 30 years. So let's find out what that payment would be. Click on the function wizard. We've already got the payment function here, so I'll say OK. And I'm going to reference the rate, which I have stored in a cell, and come back and adjust it to the rate per payment. The number of periods is going to be, I'm going to reference it, the 30 years stored in a cell times 12. Okay, and finally, I want to borrow that money, so I need it now. I need it presently. So I'll click on it, and I reference this house that I have chosen is $190,000. Wow, I wonder what this payment's going to be. Let's come back, and I can see what it's going to be. It's going to be about $1,055.08. Son of a gun. Now, I need you to understand that that amount is the amount only for principal and interest. On your monthly payment, I know from the hard way, I found out that you will also have to pay tax and insurance. And in the Montgomery County, I happen to know that that comes to about 10%. So what we could do, you won't have to do this in the homework, but I thought for interest you'd want to know. I can multiply this cell times 1.1, which will add the 10%. So I can say equals this cell times 1.1. I need the 1 for the original amount, and then the 0.1 for an additional 10%. And if I hit enter, son of a gun, my monthly payment would be $1,160, and that includes principal, interest, taxes, and insurance. That we call that PITI. Now I want to show you, I want to do this one more time and show you how much it affects, or it is affected by the interest rate, okay, on your loan. What if we have a lower interest rate for the same house in the same term? Let's go through it again. Again, we'll go to the function wizard, pick payment, and I'm going to go fast here. Interest rate, come back, divided by 12. Number of periods, go get it, come back, times 12. And finally, present value, same present value, come back and hit enter. Son of a gun, that little bit of interest rate that went down significantly changed the payment. Of course, that's principal and interest only. Don't forget that if you want to include taxes and insurance, you would multiply that cell times 1.1. to get a pretty good estimate of what your monthly payment on a house would be. And it looks like in this situation, it's still going to be way cheaper, well, significantly cheaper. Okay, so interest rate really matters when you're taking out a loan. Just a little bit of change can make a big difference in your payment. One more function, probably the most useful in my opinion. Now, when you go to buy a car or a home, how do you decide which car or which home or what you can afford? Okay, I'll tell you how not to do it. Don't look at a car. Well, my brother has this car, so I can do it. Okay, I can afford it if he can afford it. Well, that's not the way to do it. Okay, or go looking for houses and go, I love that house. I'm just going to do whatever it takes to pay for that house. That's not what you want to do. What you want to do is decide what payment. You look in your wallet, kind of a thing, or look at your paycheck every month and say, what can I afford every month? What can I afford on a regular basis? What interest rate can I get? Okay? And then we'll answer the question, what is the present value of what you can borrow? Okay? That's the realistic way of finding out what cars or houses I should be shopping for, and that involves the present value function. Works pretty much the same way. Let's do one. I wonder, using this annuity situation, $220 payment every month, The best loan I can get, we'll say, is 12% over a 5-year term. I wonder how much car will that buy me, because I don't know which one to shop for or which kinds to shop for. So let's go to the function wizard, and this time we're going to use the PV, or present value function. Okay, and there it is. And you say it works pretty much the same way. I'm going to reference the rate, which could change, but for now we're going to pretend it's 12%, and we'll come back, and as always, we'll adjust that to the interest rate per payment. And the number of periods, we've referenced the term, and we'll come back and we'll adjust that to the number of periods by multiplying by 12. And then we've referenced the payment that we think we can afford every month, and we'll point to that. And wow, I wonder what this is going to be. How much car can I buy for that much a month? Well, it looks like you're shopping for about a $9,800 car. Okay, that's the idea. And you say, well, wait, maybe I can afford more than that. Okay, maybe I can afford $300, kind of a thing. As soon as I hit enter, well, you can afford more of a car. But at least you'll know exactly what to shop for, kind of a thing. Okay. Even more importantly, let's look at homes. Okay. For instance, I know I pay $900 rent. Okay. And it looks like right now the going rate, we'll say, is an interest rate of 4.5%, and typically a home loan goes for a term of 30 years. I wonder what kind of homes I should be shopping for if I can afford $900 a month. Let's use the present value function. I'll go to the f of x. I already have present value there, and say OK. And once again, I'll go out and get the rate and adjust it, divided by 12. Go to the number of periods, 30-year term, and adjust it, times 12. And the payment that I believe I can afford, because I pay that much in rent, would be $900. And let's see what kind of a home I could be shopping for. Well, it looks like you're shopping for, that's realistic, a $177,000 home. Now I need you to consider, remember, that only involves principal and interest. So we're going to have to pay tax and insurance. So this time we're going to have to adjust and make that number smaller. Instead of multiplying by 1.1 in Montgomery County, we're going to take this cell and divide by 1.1. And the house that we'll be looking for is something reasonable. You could get a townhouse or a condo, very nice, for $161,000. That's what you would be shopping for. So the present value tells you, based on what you know you can afford, what homes or cars to shop for. Very useful. And do you see that these financial functions pretty much all work the same way? And there are more, but I think that is enough for today. So use these functions. I hope you'll practice with these functions when you do your homework on the computer.